China just listed a flying car for $4,937. That is less than a quarter of what the average American spends on a used vehicle today. Personal flight, available now for less than most people pay for a second-hand sedan. But the price is not the real story. The real story is how China arrived here while every other country was still arguing over blueprints. America has been promising flying cars since 1917. That is not a rounding error. It is more than a century of concept art, investor presentations, and breathless headlines that never produced something ordinary people could actually purchase. The first serious prototype flew in 1946. Magazines declared it the future. The future never shipped. In 2012, a Massachusetts company called Terrafugia completed its first successful test flight, a vehicle that could take off from a runway and drive on a road. That same year, Tesla launched the Model S. Two companies, two products that sounded impossible, two chances to rewrite transportation history. Tesla became the most valuable car company on Earth, its market cap crossing $1 trillion. Terrafugia never delivered a single consumer product, was quietly acquired by a Chinese firm in 2017, and most Americans never noticed. That contrast is not a story about one company failing. It is a story about where the world was paying attention. While America's best engineers were perfecting electric cars, China was watching, studying, and asking a different question entirely. Not how do we make cars cleaner, but how do we make them fly? China did not stumble into flying cars by accident. The government designated low-altitude aviation, everything operating below 3,000 feet, as a national economic priority. They funded it, built a regulatory framework around it, trained engineers for it, and did all of this while the Western world was still debating whether flying cars belonged in science fiction. By 2023, while American companies were still conducting test flights and filing certification paperwork, China had already certified the world's first autonomous flying taxi for commercial passenger operation, not in a laboratory, not in a press release, but in the airspace above Guangzhou. The vehicle at the center of this story is the EHang EH216-S. It seats two passengers. It flies itself. So when you climb inside, the first thing you notice is the absence of controls. No joystick, no instrument panel, no throttle. The cabin resembles a passenger pod because that is precisely what it is. You are not the pilot. You were never going to be the pilot. Think of it like an elevator. You press a button and trust the system entirely. You select your destination from a set of approved routes, and a ground-based AI system manages everything: altitude, navigation, speed, and landing, from a control center below. There is no override switch, no emergency control you can grab if something feels wrong during the flight. The entire journey is handled by the system from the moment the rotors spin up to the moment the skids touch down. Most people take a small step back when they hear that. The detail that changes the conversation is in the certification record. So in October 2023, the EH216-S became the first eVTOL aircraft in history to receive full-type certification from China's Civil Aviation Administration, not a test permit or a research exemption, but the same category of approval a commercial airliner must earn before carrying a single paying passenger. More than 300 units have been delivered and are currently operating. The passengers climbing into these pods are not nervous test volunteers or company employees. They are ordinary tourists and commuters who looked at an autonomous flying pod with no controls and said yes. That single fact tells you more about where this technology stands than any specification sheet. The Western flying car industry did not fail quietly. It failed loudly, expensively, and repeatedly. Terrafugia, founded by MIT graduates with serious backing, disappeared before selling a single unit. Lilium, the German eVTOL startup that raised over $1 billion, filed for bankruptcy in 2024. Archer Aviation is still awaiting FAA certification. Joby Aviation is still waiting. Whisk Aero is still waiting. and every failure left something behind: data, patents, aerodynamic research, battery chemistry, lessons learned, the brutal way, engineering talent that scattered across the industry and kept working. China was paying close attention to all of it. The common assumption is that China copies, that it waits for the West to do the hard work and then manufactures the result more cheaply. In eVTOL aviation, that story runs exactly backwards. China did not replicate Western flying cars. China watched Western flying cars fail and built something different when Lilium's jet-powered concept ran into funding walls and aerodynamic complications. Chinese engineers had already moved towards simpler multi-rotor designs. When Western startups spent years chasing single-pilot certified aircraft requiring expensive licensed operators, China built fully autonomous systems that removed the human from the equation entirely. When American companies spent years negotiating with the FAA over certification frameworks that did not yet exist, China's aviation authority was building those frameworks in parallel with the aircraft. They were designed to certify, and China did not just build aircraft, it built the entire supply chain underneath them. And carbon fiber manufacturing scaled to cost levels Western aerospace companies cannot match. Battery cell production for eVTOL applications running at volumes that push unit costs down year over year. Autonomous flight software developed inside a regulatory environment that actively encouraged testing over populated areas, generating real-world flight data that Western companies are legally prevented from accumulating at the same scale. By 2023, China had more than 30 active eVTOL companies funded and scaling simultaneously, not competing for the same slice of market, but generating 30 parallel streams of engineering progress, feeding lessons into an ecosystem that kept getting cheaper and smarter with every passing quarter. The $4,937 price tag is not a loss leader or a subsidized entry point. It is a natural output of a manufacturing ecosystem that spent a decade driving costs to exactly this level. The regulatory gap is real and worth understanding. Owning a flying car and actually flying one are two entirely different things, and the distance between those two sentences is wider than most people expect. The sky is among the most tightly managed spaces on Earth. Every corridor, every altitude band, every approach path is governed by rules written for a world where flying was something of airlines did, not something individuals did on a Tuesday morning. The FAA moves carefully and deliberately. American eVTOL companies like Joby and Archer have been navigating the certification process since the early 2020s and are still not carrying paying passengers. China solved this differently. The Civil Aviation Administration did not wait for aircraft to arrive before building the framework. It constructed the framework alongside the aircraft so that by the time the EH216-S was ready for certification, the rulebook it needed to pass already existed. Japan then did something that shifted the equation further. When an AutoFlight eVTOL completed demonstration flights connecting 3 Japanese islands whose aging coastal infrastructure had no affordable road or ferry solution, Japanese regulators did not look away. They cleaned in. A Chinese flying car solving a transport problem that Japanese infrastructure could not fix is not a footnote. It is a signal about which nations are moving fastest toward open eVTOL airspace and what they share in common. Transport challenges that traditional infrastructure cannot address cheaply or quickly. The first serious buyers tell you everything about where a technology is actually heading. The first customers of the automobile were not commuters, they were farmers, doctors, and rural delivery operators with specific problems horses could no longer solve fast enough. The pattern is repeating. The first serious buyers of Chinese flying vehicles are not thrill seekers or tech billionaires. They are logistics operators running cargo across terrain roads cannot cross efficiently, rural emergency services in mountainous regions where a flying response vehicle cuts arrival time from 40 minutes to 4, and infrastructure inspection contractors who need aerial access to power lines and pipelines without the cost of a helicopter. Every category shares one characteristic: buyers with operational budgets, specific problems, and zero interest in waiting for the technology to mature further. When early customers are operators rather than consumers, the technology gets tested harder and faster than any laboratory program can replicate. A logistics company flying cargo routes 6 days a week generates more real-world engineering data in 6 months than a test program accumulates in 3 years. And institutional buyers do not just purchase products, they build dependency. A logistics company that restructures its delivery network around autonomous flying vehicles does not switch platforms when a Western competitor eventually arrives. The routes are established, the ground infrastructure is in place, and the switching cost is enormous. Nearly 5,000 people have placed deposits on a single product that rewrites what the words flying car actually mean. The vehicle is called the XPeng land aircraft carrier, and the name is a literal description. There is a ground module, a full-size electric vehicle that drives on normal roads, and there is a flying module, a 6-propeller electric aircraft that sits on top during transit, detaches when flight is needed, lifts off vertically, then folds back down and reattaches when the flight is complete. The entire process takes 5 minutes, publicly demonstrated on film. The ground module delivers approximately 500 kilometers of driving range, and the price is under $280,000. A comparable light helicopter costs between $250,000 and $500,000 to purchase, then requires a licensed pilot, a helipad, and between $100 and $300 per flight hour to operate. The land aircraft carrier undercuts that entire proposition, drives on a normal road, and parks in a standard space. The factory is already built in Guangzhou with an annual production capacity of 10,000 units, more flying vehicles per year than the entire Western world has ever certified across its entire history of attempting to build them. In February 2026, a Chinese company called AutoFlight unveiled something called the Matrix. 5 tons of aircraft, a wingspan of 66 feet, capacity for 10 passengers, fully electric, the largest eVTOL ever constructed. Not a concept, not a render, a physical aircraft that exists and was built by the same country that put a personal flying vehicle on sale for under $5,000 in the same calendar year from the same industrial ecosystem. America's leading eVTOL companies, Joby and Archer, are both targeting FAA certification and commercial operations in 2026, and credit where it is due. Building to FAA standards is genuinely demanding work, and both companies have serious engineers doing serious things. But China already has certified aircraft flying commercial revenue routes today. It has a government mandate treating low-altitude aviation as a national economic priority. It has more than 30 funded companies scaling simultaneously, and it has the supply chain, manufacturing volume, and autonomous software infrastructure that makes every new aircraft cheaper to build than the previous one. China's low-altitude economy is forecast to reach the equivalent of approximately $480 billion by 2035, larger than the entire current GDP of Norway. The country's low-altitude economic alliance projects 100,000 autonomous drones, flying cars, and electric air taxis operating over Chinese cities by 2030. That is more flying vehicles than there are commercial aircraft currently operating across every airline on Earth combined. America owned the sky in the 20th century. It's built the jets wrote the rules, and ran the routes. The 21st century sky is being claimed right now, not with fighter jets and moon rockets, but with a foldable 6-propeller aircraft that stores on top of a car and a personal eVTOL that costs less than a used sedan. The $4,937 flying car is not the beginning of a product launch. It is the beginning of something considerably larger. And the only question is whether the rest of the world is watching closely enough to understand what just happened